so far? Okay, let's get back to our presentation. So we're back at Rick's search tool. So task number 1, we will have to merge these two search methods so that we will have only one search method, admitting not a guitar spec or a mandolin spec, but instead an instrument spec. How will we do that? Well, very simply, we will change the admitted parameter type and modify the content accordingly. We have nothing to do with these inherited classes, but what is even more interesting, these two subclasses, both guitar and mandolin, as it says here, they have nothing but a constructor. So they don't have a field. So they don't have a method that is specific to them. And even though they don't have a method specific to them, so they only have specific fields that are specific to guitar, fields that are specific to a mandolin, but no guitar-specific methods or mandolin-specific methods. Despite that situation, every time that we need to add a new instrument into this design, we will have to create one more class extending the instrument superclass, which is not exactly an ideal situation. But we will get to that step by step. The class instrument spec seems okay, except for the fact that, of course, every time that we add a new instrument type, we have to extend it once again in order to store the specification of the instrument that has just been added as well. So every time that we add a new instrument, we also have to modify this part as well. Not really practical, not at all. So these are examples of how maintenance costs increase. And adding a new instrument type is one of the changes that it's absolutely expected. I mean, it's not as if we were caught off guard. I mean, when you design an inventory application for musical instruments, naturally, you should be expecting new instruments to be added in time. Why? Well, because the person who is giving you the specifications, the person who is giving you the requirements for a project, for the design, is not a specialist. I mean, Rick, for instance, he just sells guitars. He doesn't know about software engineering or computer science, and neither does he have to. All he knows is that he will just have an inventory. He needs an inventory. He knows only what he needs at the moment. But we cannot accuse him of not telling us in time what he might need in the future. That is basically up to us. Who is us? Well, we are supposed to be the specialists. We are the ones that deal with design problems. We are the ones deal with software development. So we should be the ones anticipating. We should be the ones waiting, expecting, guessing even what will be the changes in the future. So it is up to us to ask him the proper questions. That's why usually in large companies, you will see that there are specific teams for this. People that their only job is to interact with the customers, interact and ask them the right questions in order to figure out exactly what they need and also extrapolate from this what they are going to need in the future so that they can help the other team responsible for the development to design a piece of software that will not only cover the needs that the customer has now, but it will also be easily extensible so as to cover the needs that the customer might have in the future. Of course, you might ask, why isn't the team of developers that interacts directly with the customers? Well, usually you need people with good communication skills in order to talk with the customers, and the developers, unfortunately, usually lack those skills. Of course, there are many exceptions to that. So a closer look at the search method. So of course, naturally, we are not going to have one search method per instrument. So we will need to fuse all of these into search instrument spec. Okay, so let's look at the inventory class once again. So public class inventory, of course, it will contain the list representing the inventory. This could be a linked list, a database, it could be anything, doesn't matter. So the constructor initializes the inventory object. We still have the problem with the add instrument. We will get to that later on. Now, what is that problem? Just to remember it. The problem is that whenever we want to add a new instrument, that new instrument is given to us in the form of fields, serial number, price, plus the instrument spec object, which in reality might be a guitar spec or a mandolin spec. Now, of course, into the inventory, I am supposed to add either a guitar or a mandolin object, which means I need to check. How will I know, basically, if I'm supposed to add a guitar or a mandolin? Well, the only way to figure it out is check the real type of the instrument spec reference. The declared type, bildirilem tip, the declared type is an instrument spec, but the real type, it might be a guitar spec or a mandolin spec. So if it's a guitar spec, I will create a guitar. If it's a mandolin spec, I will create a mandolin. And of course, this is very practical. Time that we also need to add one more if clause in this. Now we're going to the search instrument independent. It admits instrument spec object. It sources the event and instrument in the event. The matches method of the get spec of the spec field in the instrument in order to make sure if it matches the given instrument reference, given instrument. Of in reality, it is handling either mandolin specs or guitar specs. For us, how many instruments? It doesn't matter if you have 1,000 different instrument types supported by this inventory. This this search method will never have to change. We will remember for the add and the pair our hands aside. In order to create the actual instrument, well, you have to use new. You have to call something until the name of the. So it is an interrogation mark, a question mark. How are we going to solve the problem? How are we going to make add instrument independent, like we did with the search method? That remains to be seen. Any questions about the search method? Let's continue. That's important. That's it. Now let's look at the instrument classes. Now the instrument class takes care of all the common properties of an instrument, and each instrument subclass is a constructor specific to that instrument type's spec class. Now, what is the benefit of the subclasses? So guitar, mandolin, and so on. Now, do they have any fields that are specific to the show? No, they don't. Because the fields that are specific to the are located inside the spec class. So whatever is specific to a guitar, such as the number of strings, so 5-string or 6-string guitar and so on, is stored. Whatever is specific to a mandolin, such as the style of a mandolin, something that doesn't exist in other instruments, is stored in the mandolin spec. So what is the purpose, in fact, of these classes? Well, the only thing that they contain so far is very simply a constructor. Simply a constructor that calls the superclasses constructor, initializes some fields, and that's it. They're not doing anything else. So they're not really I mean, are they really integral? Are they really critical for our project? However, our book says that classes are really about behavior. Now, I know that I learned before in the past that whenever you have a new concept, a different concept, you should represent it with a different class, especially if it has distinct fields from other classes. So for instance, if class A contains a certain field that doesn't exist in other types of classes, well, it should definitely be a different class. I mean, that's what you have learned. Or if it represents a different semantic concept, anlamsal manada farklı bir mesleği, farklı bir kategorideki, sınıftaki olguyu, kavramı ifade ediyorsa ayrı bir sınıf olmalı diye öğrendiniz. However, here, this is but it's causing us too much trouble. It is increasing the maintenance costs. So we have to limit a bit those.
Hocam gittiniz sanırım, düştünüz.
Görüntü 6 dakika geride kalmış.
Can you hear me now?
Yes.
Yes.
Okay, sorry for that. I guess they started teaching in the other classrooms as well, and there was an overload on the network. I switched from wireless to the Ethernet, so it should be fine now. Okay. Now, yep. Let's share our screen once again. Okay, I guess you can see my screen now. Are we recording as well? Yeah, yes, we are. Excellent. Now, as I was, what was the last thing that I said before I was cut off? Do you remember?
Hocam bir 5 dakikadır kesik kesik geliyordu aslında.
So what is the last thing that you remember?
I wrote to the chat, but I think it is not coming. I just Here a declarative word when you mention an instrument method. I mean last 5 minutes, I guess.
Okay. No class. Concerning the declared part, there isn't really much going on. So I guess this is the part that you mentioned, right?
Yes, here.
Okay. So basically here there are two things that are going on. Now we have the add instrument method, which is used in order to add instrument objects into the inventory, into the database, if you will. And then we have the search method, where given a search spec reference, we search for the matches to it. Now, initially or previously, we had multiple search methods, one for each type of instrument, which was stupid, to be honest. So what do? We have fused all of them in such a way that they will admit an instrument spec. And in this way, Mr. Akif says, I didn't say declarative type, I said declared type. Declared. Be careful. There's no such thing as declarative. Declared type versus real type. Remember that. So real type is the actual type of the object, the one that you write after the new keyword. New anahtar sözcüğünden sonra gelen kısmı gerçek türü, real type. And the declared type is the one that you have on the left side of the assignment. Yani şeyi ne derler? Patlıcan P eşittir veya pardon sebze S eşittir new patlıcan. Sebze is the declared type and patlıcan is the real type. So sebze is the declared type and patlıcan is the real type. That's the idea. Now here, of course, the declared type is an instrument spec, but of course the real type will be either a guitar spec or a mandolin spec or so on. And as you know, in Java, on the contrary of C++, where we have the concept of virtual functions, here, whenever you access a function, it goes, of course, all the way down to the subclass. It goes all the way to the real type in order to get the version of the function to execute. So there is no confusion about whether a function is virtual or not. So that is specific to C++. Okay, so what does this mean for us? It means that with this search method, we are basically now independent of the instrument type. We can use it with any instrument type. We can have 10,000 different instrument types even, and we will still be able to just give it an instrument spec and use this method even when new instruments are added every day. However, we have a similar problem with add instrument, but we don't have a solution for it. Because here too, whenever we are given the pieces, the field values of a new instrument to add into the system, such as the serial number, the price, and the instrument spec, which in reality is either a guitar spec or a mandolin spec, we have to actually use the new keyword in order to create the object. And how do we know which kind of object do we have to create? Well, the only way that we can know is we can check using instance of in order to figure out what is the real type of instrument spec. Is it a guitar spec or a mandolin spec? And depending on the outcome, we either create a guitar or a mandolin. Now, what we want is to make add instrument, this method, the method add instrument, as instrument independent as the search method. However, that will prove to be a bit difficult because we have to use the new keyword in order to create the actual instrument. So how do we escape? How do we get rid of this necessity to use if clauses for every instrument? Checking with instance of, this is not elegant, zarif değil. And besides elegant, zarafetten de öte, this is expensive in terms of maintenance because it means every time that you add a new instrument into the project, you will have to add new lines to the add instrument method. So this remains to be solved. Now, how do we approach that? Now, this brings us to the next part. Now, in the past, in your courses of object-oriented programming, software engineering, I mean, I am guessing that you were told, just like I was told when I was a student, that whenever you have a new concept, kavram, whenever you have a new concept in your project, you should represent it as a different class. More specifically, if that concept has different properties, even from other concepts, from other classes in your project, then you should definitely represent it as a new class. Here, however, if we look at the case of instruments, such as guitar, banjo, dobro, mandolin, fiddle, and so on, and we look at the actual contents of those classes, we see that, for instance, public class guitar extends instrument. And all it does is, basically, all it contains is just a constructor. A constructor that admits all the parameters, calls the super constructor of the superclass, and that's it. Now, doesn't the guitar have fields that are specific to a guitar? Yes, it does. So where are they? They are in guitar spec. Just like the fields specific to a mandolin are in mandolin spec. Now, this is causing us issues. This is causing us problems. The problems that we just saw with the add instrument method. Now, if we want to solve that, we need to change the way that we think about this problem. The way that we think when we decide about when should a concept be represented by a new class or not. And the gurus, the masters, the specialists of this area, and I am not one of them, the gurus, the specialists, they say that classes are about behavior. So you need to ask yourself before creating a new class, does it function differently with respect to the classes that I have? Does it bring in a new behavior to the table? Bu kavramın diğer kavramlardan farklı bir davranışı var mı? Yani farklı bir yöntemi, metodu var mı? If it does, then you should definitely have a separate class for it. But in the case of the instruments, there is no distinct behavior. A guitar does not have a method that is specific to a guitar. It doesn't have a guitar-specific behavior. For instance, if it had a method for play guitar in order to produce a sound, okay, that would be a distinct behavior because banjos, guitars, mandolins, they don't produce the same sound. But here, no such thing is happening. So why have them as distinct classes? As our friend here says, guitar and mandolin are the other instruments. Guitar and the other instruments have different behavior, but they don't have a different behavior. They don't have a different behavior, but they have different properties. So he thinks that we should have subclasses for each instrument, right? No, because all the instruments, at least from Brick's perspective, they behave the same. What is the purpose of an instrument in this context? The purpose of the instrument is just to encapsulate the fields that represent it. Her müzik enstrümanının bir sınıf olarak, yani bu projede yer aldıkları şekilde tek amacı ona özel alanları paketlemek, içermek. Bir davranışı falan, bir yaptığı bir iş falan yok. Sadece paket halinde, abi ben gitarım, işte arka ahşap, ön ahşap, işte tel sayısı, markası, modeli falan filan. İşte ben mandolinim, bende de ayrıyeten bir tarz alanı var, tel sayısı yok falan filan. İşte diğeri bas, diğeri flüt, diğeri keman, piyano falan. O sadece alanlardan ibaret. They have no different behavior, no specific function to them. So, basic OOAD principles, add flexibility. How can we add flexibility? How can we turn this situation to our benefit? Bu durumu nasıl bizim lehimize çevirebiliriz? Nasıl yararlanabiliriz bu durumdan? We are continuing to solve this problem. Now, here is just an example of where we used which object-oriented principle. For instance, inheritance, where has it been used? We are using inheritance already with the instrument and instrument spec classes and their subclasses, but it does seem like the instrument specific subclasses don't actually do anything but just inherit from instrument. They just have slightly different constructors. Where do we use polymorphism? We use polymorphism in the search method to treat all instruments as instances of instrument instead of worrying about whether they're a guitar or a mandolin. So searching becomes easier. But it would be nice to be able to use this principle in add instrument too, to cut down on some repetitive codes, such as those if clauses that we had in the add instrument. Abstraction. Instrument spec abstracts the details about each instrument specifications away from the instrument class itself so that we can add new instrument properties without affecting the basic instrument class. And of course, finally, encapsulation. That's where we separated instrument from instrument spec. We are using encapsulation a lot, but maybe we can use it even more. Remember, encapsulate what varies. Since the properties in each instrument type are what varies, can we somehow encapsulate those properties away? Since the properties in each instrument type are what varies, can we somehow encapsulate those properties away from instrument and instrument spec completely? Now that's an excellent question. What varies in our program is basically just the fields of the instruments that we're dealing with. Guitar has a builder and model and the number of strings. Mandolin has a style and a builder and a model, and so on and so on. Those are the only things that vary basically from instrument to instrument. And the instrument classes are just collections of just fields, of such fields. So how can we encapsulate that? So these guys have come together in order to think about this situation. So they say, okay, what's our principle? Well, the principle is to encapsulate what varies. Exactly. And we know that the properties for each instrument are what varies in the application. So how are we supposed to do that? Well, what we have done so far is basically just to have an instrument class, which is which was supposed to be abstract, and which contains an instrument spec. An instrument spec basically just is extended by guitar spec and mandolin spec. So these guys, they say we shouldn't have classes specific to the instrument since they only differ in terms of constructors. And instead, they say we should have a concrete, not abstract, concrete instrument class. That's why it is no longer in italic, as you can see from the name of the class. What would be the advantage? Well, the advantage would be that we wouldn't need to create a new instrument class. So if you add a third instrument, such as a piano, you wouldn't need a piano class for this. You would simply just create an instrument class, which would contain all the fields to it inside the instrument spec. And if by any chance you have any fields that are very specific to a certain instrument type, such as the number of strings in the case of guitar spec, you would have a specific subclass, such as in the case of piano spec. There is some noise coming from somewhere. Okay. So if we convert the instrument class into a concrete class, we no longer need to create separate classes in order to represent the instruments. Instead, whatever fields we have belonging to that instrument, they are encapsulated, they are represented by an instrument spec class. And if by any chance we have any fields that are very specific to a certain instrument type that never before existed in our project, we can very simply still continue to have a spec class specific to that new instrument. So in the case of piano, a piano spec class, and so on. So what is the advantage of this? The advantage is that instead of having two new classes per instrument, so if you add a piano, you will have a piano class and a piano spec class. Instead of two, you will only have one new class, just the piano spec class. That will be an advantage, but is that enough? No, it's not. But at least, well, it's half the classes. Instead of two, it's one. At least we have avoided the unnecessary piano class, which would only contain a simple constructor. Now, at this point, of course, we have changed a bit our design. Yes? Who is speaking?
Salih.
Salih. Okay, Mr. Salih.
I don't know how I missed it, but I didn't get why instrument class should be concrete class instead of abstract.
Now, Mr. Salih, the problem is that as long as it is an abstract class, that means for every instrument, you have to create a subclass. I mean, you have to, if you want to create a guitar, a mandolin, and so on, in order to add it to the inventory. And if you choose to go in that direction, we are faced with the problem that we had with the add instrument method, which was right here. This very impractical situation where we have to create a new instrument object, so either a guitar or a mandolin, depending on the instance, depending on the specific real type of the spec class. So if you have a new piano, you will need a third if clause right here in this method. If you have 100 different types of instruments, you will need to have 100 different if-else clauses inside this method. Now, by converting the instrument superclass into a concrete one, we are basically trying to avoid even the necessity to create those classes. So if it is concrete, that means we no longer need to have subclasses such as guitar and mandolin. So this gives us a chance to improve a bit the situation at add instrument. But how exactly? Let's take a closer look. Here, a small parenthesis, the death of a design or a decision. Now, we had started ever since the beginning to use an abstract instrument class, and now we are changing our design a bit radically. Now, even though it is often very difficult to make such radical design decisions, because that means you have to change a lot of stuff, basically, the book says, do not be afraid of it. Just because it seemed to make sense at the time, and it is hard to change something you thought was already working. Yes, it made sense at the time, but the more we studied the problem, the more we witnessed the additional issues that we encountered during our design adventure, we have decided that what made sense at the beginning no longer makes sense. And long story short, zararın neresinden dönsen kârdır. Even if it hurts, basically, to modify your design radically, you still should go with a design that suits most your requirements. You shouldn't be afraid to make radical modifications, because if you choose to go with a bad design, just because it costs a lot of time and money to modify it now in terms of design, it will cost you even more in the long run once it is implemented. So the principle is code once, but design multiple times, instead of design once and code 100 times. 10 kere tasarla ama bir kere kodla. Design is iterative, and you have to be willing to change your own designs as well as those that you inherit from other programmers. If you have to change it, then you change it. It is always better to change your design than using a bad design and then having to change bad code afterwards. So, by turning the instrument class into a concrete class, we no longer need these 6 classes. So guitar, banjo, mandolin, fiddle, etc., etc., etc. So what does it look like now? Well, we have a concrete instrument class. The instrument class contains, be careful to the arrow, it contains an instrument type field, basically, which represents the type of instrument that we are handling. So we have a serial number, the price for the instrument, and of course the specifications for that instrument. Now, this is a huge improvement. It is a huge improvement because we have just saved ourselves from 6 additional classes. Or from, if we have n instrument types, we have just deleted n classes from the system. Now that is an improvement worthy of mentioning. Okay, but what about the specs? How can you expect this instrument spec to represent all of those different specifications for all of those different kinds of instruments? Let's continue. Double encapsulation. Where is this double encapsulation? Now, here is the first one. Here is the second one. Let's look at the layer of encapsulation we already have, and then see how we can add a little more encapsulation to get those properties that vary out of the instrument spec class. Now, encapsulation numero uno. Instrument spec represents all the fields, the common fields, the common fields of all the instruments. So builder, model, type, backwood, topwood, so on and so on. So that is encapsulation number one. We have taken all of the common fields to all the instruments and we have placed them inside instrument spec. Now the problem is that these properties vary across instruments. So we are having to add a subclass for each type of instrument. What is the issue? The issue is that these are only the common fields. For instance, guitars have a number of strings, whereas mandolins don't. Mandolins have a style, whereas guitars don't have a style. Pianos have a number of keys, maybe. I don't know. I'm making it up. Or another property that other instruments don't have. So as a result of that, we have to create subclasses for each instrument spec. So mandolin spec, guitar spec, piano spec, in order to store those properties specific to those instruments. So how can we get rid of that? We can get rid of that by using, for instance, a different data structure. By using, for instance, inside of instrument spec, instead of having a subclass for every instrument type, so piano spec, guitar spec, mandolin spec, and so on, instead of that, we can very simply have a map in the traditional sense, in the sense that you saw it in data structures, which contains the properties. And of course, it is a map because it contains couples of values. What kind of couples? For instance, instrument type, guitar. Builder, Martin. Type, acoustic. Style, style F, and so on and so on. Now, what about some instruments that don't have certain properties? For example, guitars don't have a style. Well, very simply, in the case of a guitar, the instrument spec corresponding to a guitar, very simply, will not have that property. So it will be a map that doesn't have the style value or key. Whereas in the case of guitar, you will have the number of strings, and the mandolins will not have the number of strings property inside their map. That's the dynamic part. So for every instrument type that you're representing with the instrument spec, you simply add the type of the instrument as a field, as a pair of key and value inside the map. Now that means we no longer need subclasses, guitar spec, mandolin spec, and so on and so on. So that means even if you have 1,000 different instruments, you still need just one instrument class and just one instrument spec class. And the part that varies specifically for each instrument is located inside the properties map. So basically, we just took what varies inside the instrument spec class and put it inside a map. When you have a set of properties that vary across your objects, use a collection, like a map, to store those properties dynamically. Now, this only works because the objects that we're trying to represent through this map, through the varying properties inside the map object, do not have distinct methods. A guitar doesn't have a guitar-specific method. A mandolin doesn't have a mandolin-specific method. That's why I can do this. If they had specific methods, then I wouldn't be able to use a map in order to represent all of these objects. And this is what our design looks like now. So just an instrument, an aggregation, an instrument contains an instrument spec, And an instrument spec basically just has a map with all the properties representing each instrument. And what about the inventory? And of course, we can use, .get spec and .get property in order to access the values inside the map naturally. So let's get past the instrument spec. I mean, nothing much has changed in that regard. You just have to use a map in order to access the properties inside the matches field. Nothing extra, as you can see from here. So the instrument spec, just very simply in its constructor, it receives a map. It assigns it to the internal map field. Be careful, the instrument spec map is admitted from the exterior. So we are assuming that the map is already ready and given to the instrument spec in its constructor. And in matches, well, not much has changed. You simply access them by using the keys inside the map in order to make the comparisons for equality. Now, let's get past this. Go. So we have the instrument types, which is simply an enumeration. So guitar, banjo, dobro, fiddle, and so on. And let's look at inventory now. Now, fortunately for us, we no longer have to deal with the very cumbersome and impractical else ifs in the add instrument method. Very simply, when somebody gives us the serial number, the instrument spec, and the price, we just create an instrument object, and that's it. So even if somebody in the future adds new instrument types into our design, there is nothing to change inside the inventory class. Now, this is how you reduce maintenance costs. Even if you add 100 new instrument types into the project, even if the customer wants 1,000 new instrument types, you have nothing to change in the inventory class. What do you change really? Well, let's say that the customer wants to add a piano into the mix. Well, that's okay. They can continue using the software as it is. If a piano has a new field, well, piano is a new type of a instrument type. So we will just have to add in instrument type here, comma, piano, bass, mandolin, piano. That's it. And we'll just have in switch this a case for piano as well to convert it to a string. If you have fields if you have properties specific to piano, well, you simply just add them to the map whenever you need them. Do you modify inventory? No. Do you create new classes? No. That's how you reduce maintenance costs. And here is the final design. Inventory using instrument. Instrument contains instrument spec. And of course, we have these enumerations in order to avoid string comparisons. As simple as that. But does it actually work? Let's look at what it looks like in practice. So public static void main. Class, a small question. If I remove the static method, if I remove the static keyword from public static void main, what will be the result?
Can you repeat again, please? I couldn't.
If I remove the static keyword from public static void main, what happens?
Main must be static, right? For Java.
I'm sorry?
Main must be, I guess, static in Java.
Yes, but why?
It must be independent from an object of class, I guess.
Well, that's what staticness provides. Being independent from an object. So basically, it makes the method not an object method, but a class method. And the main method needs to be a class method. It needs to be, you need to be able to execute it without having to create an object first, because in order to have the object, you first need to run the program. So how can you run the program if you first need an object in order to run the program? So it makes perfect sense for the main method to be static. So another question, what if I what if I do not give it any parameters? What if I write it as public static void main, but with empty arguments? So just a parenthesis, no string args. Will I still be able to execute the program? If I change the signature of public static void main? String args'ı kaldırırsam main'i yine çalıştırabilir miyim? Yes, no? And the answer is no. I mean, you can still use it as a method, as a static method, but it will no longer serve as the main method starting your project. So the signature has to be preserved. So what is happening inside this main method? Well, basically we create the inventory object. So somebody has to initialize it. So add in stuff inside it. So we are guessing that initialize inventory somehow initializes this inventory object. And now let's say that we want to add an instrument. So what do? Not add an instrument. Let's say that we want to search an instrument. Sorry, not add, search. So we are assuming that the instruments have been added during the call to the initialize inventory method. So how do you search for an instrument? You create a map and you add in only the fields, not unnecessary fields, only the fields and values, only the keys and values that you want to be searching for. So for instance, the builder, we want it to be a Gibson, and the backwood, we want it to be from a maple tree. I put them inside the map. I create an instrument spec using this map, and I very simply call the search method using this instrument spec. I get the output, and if it is not empty, I very simply just print them on screen, and that's it. And as we expected, it works pretty nice. And how does the initialize inventory part look like? Well, that part is not really that nice, but there is no way of avoiding it. Somebody needs to enter those couples of keys and values. So you create your map, you add in all the fields, all the keys and values corresponding to that instrument. So instrument type, guitar, builder, Collins, model CJ, type acoustic, number of string 6, and so on and so on. Plus, of course, the serial number and the price is quite expensive, $4,000 for a guitar. Wow. And then you simply create a new instrument spec object with the properties along with the serial number and price and give it to the add instrument method, and you're done. So you have to do this for every single instrument of your inventory. But still, does it reduce maintenance costs? Absolutely. You have less classes, and what is more important than less classes is to have classes that are not that interdependent on each other. So the main idea should be that you should have only one reason to change that class. Bir sınıfı değiştirmek için tek bir sebebiniz olmalı. Yeni bir enstrüman bekleyeceğim. Tamam, sebebimiz o. Bu sınıfı ben o zaman değiştiriyorum sadece. Mesela public enumeration vardı, instrument type. Yeni enstrüman geldi mi orası değişiyor. Veya diğer sınıflarda. You should have only a single reason to change every class. If you have more than one reason for changing a class, that means your design is not optimal. That's the main idea. Okay, I guess we are done with Rick. Now here it mentions again and again and again the same stuff. Now, before we leave Rick's guitar shop behind us and before we take a break, do you have any questions? Bu yaptığımız örnekle ilgili arkadaşlar kafanıza takılan, aklınıza takılan herhangi bir şey. Hocam şurayı niye öyle değiştirdin? Burayı niye böyle yaptın? Oradan ne elde ettin? Anything you want to ask? Derse de maşallah 40 kişi kayıtlı, gelenler 20. Sonra da hocam kontenjan artır. Okay, class. Well, in that case, we will take a break for 10 minutes, and then we will continue with the strategy design pattern. I'm stopping the recording.